Alrighty, our next two examples, as promised, bonus examples on application of vectors is here. And make sure, children, that you are strapped with your TI-84. And remember, yo-ro, you only round once. At the very end, let's get popping. So we got G-Eazy and ASAP Rocky are starting a moving company with no limit, I looked it up on the internet, on how much they can move. The first job requires them to push a box on flat ground. They haven't been able to get moving equipment yet, right? They're starting from the bottom, like Drake. Now they're here. Eventually, they got to get moving equipment, but they're making money right now to get that. G-Eazy is pushing with a force of 150 pounds at a 65-degree angle from the positive x-axis. And ASAP is pushing with a force of 95 pounds at a 47-degree angle from the positive x-axis. The box has a force of friction that is 50 pounds parallel to the ground. What is the resultant direction of the forces on the box? So we're not looking for the actual force on it. It's just the direction. Okay. So let's go ahead and get a little marker going here. Sorry, I froze up there for a sec. Hopefully that doesn't happen anymore. Let's see here. Let's get ourselves a nice little graph here. And then, so we have a 65-degree angle, right? That's G-Eazy. And that is 65 degrees. Whoosh. And then I'll go green for this one. ASAP, he's 47 degrees. Woo, 47 degrees. Okay. And then the box itself, or excuse me, the friction, working against them, right? Parallel to the ground. And that would be, so that's 180 degrees, right? If we're going back that way, 180 degrees. And that is 50 pounds. Okay. So let's see here. Let's write out our force vectors for each one. So for G-Eazy, let me go back to pink there. So force 1. So he's got 150 pounds. So that's 150 cosine, and that was a 65-degree angle. So not nice trig values, right? I hat plus 150 sine of 65 j hat. All right, that's the first one. Then ASAP, going green, that'll be force 2. And here we've got ourselves, what was it, 95 with a 47-degree angle. So 95 cosine 47 I hat plus 95 sine, almost made cosine, 47 j hat. So there's force 2. Now force 3, that's our friction, right? The friction of the ground there. So then we said that was 180 degrees, right? And that's a 50-pound force of friction, right? So 50 cosine of 180 I hat plus 50 sine of 180 j hat. All right. So now if we want to get our resultant vector here, we could just add all these together. Now they aren't nice, except for the last one there. They're not nice trig values. So we are going to be busting out that TI-84. So get that ready. Strap up. All right. I'm going to go orange for our final one because that just seems fun. All right. So all of them added together. Let's bust out that TI-84. All right. So we're going to take all of our cosines, all of these guys, all the I hats, add them together. All right. I'm going to pause for that so I can type them all in because that takes a little while. All right. So add them all together. Make sure you're closing your parentheses at the end of each one. Otherwise, it'll be part of that cosine function. We don't want that. So add all three of them together. I got 78.182583, blah, 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 blah. Remember, yo-ro. So how do we do that here in this? I'm going to store these. And I'm going to store it as A, because that makes sense when we're talking vectors here, right? Oops, I need to hit store first. Store, alpha, A, enter. Donezo. Now, let's get B. Alrighty. So there we are. Get all three of those added in there. Now, you didn't really have to add the sine of 180 because that's just 0, but whatever. I put all three in there. So now I'm going to hit store. Then alpha, we're going to store that as B. Okay, there we go. All right, so now it wants us, we want to find out what direction is this going, right? So they're pushing it. It's going to be in that quadrant 1, right? They're pushing it. They got the bigger forces pushing it in that direction than the friction that's working against them, right? That wouldn't make sense if the box was moving backwards on flat ground. But there is some resistance there, right? So if I want to figure out what the direction is, well, I'm going to take the tangent inverse of my B, alpha B, over alpha A, right? Y over X. We get 69.164 if we do 3 decimal places. So we've got, that is the resultant direction that we have going on for this one here. Storing the numbers in your calculator is super helpful. That way you're not rounding along the way, because if you start rounding and then you plug in, the number's going to be a little bit different, right? YORO. You only round once. Custom made. That important. All right, let's do uno más. All right, so we had one like this earlier on. We got a plane traveling 300 miles per hour in the direction of 210 degrees from the horizontal, so from that positive x-axis, encounters a wind of 56 miles per hour in the direction of north 52 degrees west. So we've got 2 different types of direction going on here. One in our trig, right, from the positive x-axis, and one as compass direction. What is the resultant speed and direction of the plane? So let's draw this up. So I'll start with, we'll go purple again. And we've got north up here, right? So first off, we got the 210 degrees. I'll do the plane in green. So 210 degrees from the positive x-axis is going to be right here. 210. And then we said that one's 300 miles per hour. So 300 miles per hour. Then the other one, the wind, I'll go blue. That sounds fun. So the wind is north 52 degrees west. Well, remember, west is this way. I feel like blue's not drastic enough. I'll go orange. 52 degrees west. So I'm going to be off of that north line a little more than 45 degrees, right? So my actual trig angle, because that's the one I'm going to want to calculate with, my trig angle is going to be, let's see here, 90 plus 52 would give me 142. Okay? Now, often we don't measure, with trig, we never measure it off of our vertical axes, right? Never went off the y-axis. It was always off that positive or negative x to get our reference angle, right? Well, now that we've got compass directions starting from the north or from the south, we're going to be using those, so be very careful with that, all right? And this is a 56 mile per hour. Okay, so now let's set up our 2 vectors. So we got our vector of the plane here, right? So vector for the airplane, or sorry, yeah. I don't know. I feel like A is confusing because it could be air. So let's go with the plane. And let's see here. We've got 300 cosine of 210. Oh, what a lovely trig value. I hat plus 300 sine of 210 j hat. Anyone ever forget which way the I and the J go sometimes? I've second guessed myself. All right, next one. We've got our wind, W. So that is 56 miles per hour. Why am I putting miles per hour? Cosine of 142. So that's not a friendly, wonderful trig number. And then we got 56 again, sine of 142. So to get that resultant speed and direction, we're going to need to add these 2 together. I think I'll use blue now. Okay. Alrighty. So we've got our values stored in the calculator for A and for B. As you can see, I got negative 303.936, so on and so forth, and then negative 115.5229, so on and so forth. All right. So we got them stored in our calculator. Let's jot those down. And there we go. So notice a little dot, 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 right? It continues on. We didn't round. We didn't, we're just writing down a few values there. So we want to find the resultant speed and the direction. So speed, that's our magnitude, right? So I will do square root of negative 303.936 squared plus negative 115.529 squared. Pop that in the calculator. Now, the calculator makes it super easy because I've already got my values stored, right? Okay, so let's go with second square root. And then I got alpha A squared plus alpha B squared. Love the stored values. So convenient. And we end up with 325.150 miles per hour, right? 325 what? Gotta have them units. Miles per hour. Woo! All righty. Now, what direction is this thing going, right? Well, I don't know. It's probably going like a little bit more. I'm guessing, since the wind is coming like this, it's going to be a little less than 210 degrees. But let's find out. Let's find out. Okay? So let's do tangent inverse, right? Second tangent. And then we've got alpha B over alpha A, right? Because it's our y over our x. So we got 20. Well, hold up. We got to interpret that, right? Because this plane is flying 210 degrees. There ain't no way this plane is now flying backwards due to the wind, right? That is my reference angle. So we do have to take that into consideration. So if I were to take, we know that's going to be in the third quadrant for this one, right? It's not going to be enough wind to make it go way up. So we do have to do a little bit of practical thinking here. So if I do 180 plus that, so plus 180, this will give me my actual direction, which is 200.811 degrees. So direction, 200.811 degrees. Right? We do have to do a bit of thinking. We can't just put that 20. That would mean that the plane was flying this way now. What? That's a terrifying wind. I don't think we don't even want to be flying in that, right? So if that's my direction as far as like a trig value goes, could we write that as, let's see here, it's like a compass direction, right? So we're heading, so that's like right here. That's my resultant vector, right? We said that was 20 degrees off of this guy, right? Okay. So when we're talking about compass directions, if we said south, how many degrees west, right? Because that's what we're doing there. We're going, how many degrees west? Right there. Well, if this was the 20-ish, whatever that was in the calculator, I'll pull it back up. Could we get the other one? Yeah. So if I find out what that little void is right there, I had the 20.81127, blah, 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 blah. If I did 90 minus that, 20.81127, I'm being excessive here, but you know, yo-ro. Hit enter. 69.1887, so 69.189 degrees west. There it is. There it is. I like it. So either one of those is acceptable. If it says to give it in compass directions, you would do the second one. If it says trig is fine, you would do the first one. All right? Hopefully that helps. And then you guys enjoyed these wonderful, fantastic, fun vector application problems. Have a wonderful day. America, freedom, rock and roll, Costco. Riverdog Jenny on the gram. Don't forget YORO. You only round once for mathematical accuracy. Have a wonderful day.